At this point in our project, we create the apple picker widget in the apple picker game mode. Then we handle game over and print a string to inform us whether we have won or lost the game at the end of the game. Now in this lecture, we want to set up a widget that will display whether we have won or lost the game, instead of us relying on that print string. Currently we have this widget that displays getReady, and it also contains the logic to set that widget text in such a way that it represents a countdown timer. Eventually we want to end up with a single widget blueprint that will contain all of this logic for both our countdown timer and also for the game over text. However, you can also set up multiple widgets if you want, so I will begin by demonstrating how you could do that, and then later we will come back and we will sort of unify those widgets in a single widget blueprint. In the content browser, let's duplicate our apple picker widget blueprint. I will name the new widget WBP_GameOverText. This will be the widget that we create when it is game over, that is at the end of the game. Let's open that up and change the widget. I will name that text widget GameOverText. Set the default text to game over. In the graph, I will remove the logic we have here. With the setup, how do we display that? For an exercise, display the game over widget at the end of the game with the appropriate text, so game 1 true or game 1 false. To get started, back in our game mode blueprint, remember we handle game over here. We don't need to print this debug information to the screen anymore, so let's uncheck this print to screen. We can keep logging that if we wish. Next we need to create the game over widget, so we need to instantiate that, just like we do here at Begin Play with the apple picker widget. From that print string, create widget, select the game over text widget blueprint, and of course we want to add that to the viewport. At the moment, the widget will construct and display the widget, but it will not display whether we have won or lost the game. We need to actually set the text on the widget. Remember, we do this by getting a reference to the text widget, then we use the function setText on that. If we go back to our game over text widget for a second, remember we have this game over text widget, which, if you go back to the designer, is a variable. Back in the game mode blueprint, let's drag off from the blue return value of this create widget operation and get the game over text. From here, we want to set the text. Drag off from the return value of the append operation and hook that into the text. As a recap on event handle game over, we get passed a boolean true or false depending on whether we have won or lost the game. We cast that to a string and append that to the game 1 literal string. That gets converted to a type of text, and we use that to set the text on the game over text widget. Remember, there's a difference between the string and the text types in Unreal. The toText operation here takes in a string and converts that to a text type. Then the setText operation takes in a type of text. If I compile now, I actually get this error: the game over text could not be found. So I'll go back to the game over text widget and compile the blueprint, go back to the game mode and compile again. This time it should work fine. If we play now, at the end of the game we should get that widget text. Let's test both the win and the lose conditions here. That works fine for now. Of course, it's still a sort of debug test that we display here, but we will change that later to you win and you lose, for example. Now that we have the start and end game widget text, we also want to set up a widget that will display how many apples need to be collected to win the game. I will close off the game over text widget blueprint. I don't want to keep too many editors open at a time, since that could confuse people. Back in the apple picker widget blueprint, in the designer, let's drag in another text widget. This will be our apples collected text, so I will set that to be our apples collected text. Of course, you could also duplicate the other text widget if you want, but I will start off by creating a new text widget instead. I will check size to content, and for the anchors, you can decide where you want to put the text. Notice we can hold Shift to update the alignment to match, and Control to update the position to match. So Shift click and Control click to anchor and position to the top left. You can also set the shadow if you want, as with the previous text widget, so I will set the alpha to 1. Let's set a placeholder text, something like apples collected score. Press enter to confirm, and that should update in the canvas. We also want to check this is variable so that the apples collected text will show up as a variable in the graph. Compile and save. If we play now, the apples collected text shows up. Currently we are instantiating the Apple Picker widget blueprint in the Apple Picker game mode blueprint on begin play. I want to demonstrate how we can do this in C++, so let's disconnect that execution wire, and I will comment these nodes here to do instantiate in C++. Of course, if we play now, our widget won't show up. Only the game over widget will display at the end of the game. Remember, we create the game over widget on the handle game over event, so that is why that still shows up. Let's create a new C++ class for our widget. Tools, new C++ class. You can go to all classes and search for the user widget if that does not show up under the common classes. So under visual we have widget and then user widget. Select user widget and click next. Name the class Apple Picker widget or Apple Picker widget base and click create class. I will click reload here. In the header, we want to create a function that we will use to pass in the amount of apples currently collected and then the amount of apples that we have to collect in order to win the game. We will then display those passed in values by setting the apples collected text. Let's name the function setApplesCollectedText, and for the arguments we want apples collected and apples to collect. Those will be int 32. Decorate that with the uFunction macro and specify this as a blueprint implementable event. We also want to display the game over text using this widget. We won't use the game over widget blueprint as we have done before. That will depend on the project and what you want to do, but we will try and use only a single widget for this project. Let's declare a setGameOverText function, which will take in a boolean argument, so b1game. If we win the game, we will pass in true, if not, then false. Decorate that with the uFunction macro and specify that as a blueprint implementable event as well. We can copy and paste the existing decoration here. We will invoke these functions in the game mode, but what happens when they are invoked will be defined in blueprints. Remember, in the Apple Picker widget blueprint, we defined this time remaining variable. Now, since we know that we will need a float to keep track of the game start delay, let's declare a variable for that in C++. Remember, we also have this variable in the game mode, so I will navigate to the Apple Picker game mode header. And before we copy this, let's specify this as blueprint readWrite, since we want access to that in the blueprint graph. Copy that and paste that in the Apple Picker widget header. These variables do have the same name. You may want to change that if you want to avoid confusion, but of course, this is fine since they are owned by different objects. Actually, let's close off the editor for now since we are making so many changes. Previously, we created, or in other words instantiated, the widget object in blueprints. But I want to demonstrate how we can instantiate the widget and add it to the viewport in C++. We will choose which widget we want to create and add to the viewport from within the game mode blueprint using the T subclass of, and then we will instantiate that and add it to the viewport in C++. So let's navigate to the game mode header again. In the protected section, let's declare some properties. One will be for the user to select the widget type that they want to have be instantiated when the game begins, and the other will be the pointer to the managed widget object in memory. So for the first property, we will use T subclass of, since we want to basically filter and only make the uSerWidget class and derived classes selectable by the user. Remember that the Apple Picker widget class that we just created here derived from uSerWidget, so that and our blueprint derived classes will be selectable by the user if we provide uSerWidget as the type argument for the T subclass of. So class uSerWidget for the type argument, and I will name this game widget type. Decorate that with the uProperty macro, specify this as edit anywhere, and this will be in the widgets category. I will add a comment on why this is here to specify the widget blueprint or type in the editor. Then we want some pointer which will point to the managed object, which I will name widget. Decorate that with the uProperty macro. We will allocate the widget on begin play if game widget type. So if we have specified the widget and that is not null, then we want to allocate an object of the specified widget type and assign the address to the widget pointer. To do the instantiation, we can use the function createWidget. Pass in a pointer for the owning object. In this case, I'll use getWorld. And for the next argument, we pass in the user widget type, which we would like to instantiate. And for that, of course, we have the game widget type. Remember, we will select the actual type in Blueprints, and that type will be assigned to this game widget type. This will return a pointer to the type, so let's cast to our apple picker widget type, just to make sure we have the apple picker widget type. Because we want to invoke those functions that we have declared previously, we need to include the header for our type. I actually named that uApplePicker widget base, so I'll just make sure to fix that here and also in the header for the widget pointer. This is why it's often a good idea to copy and paste the types. Now if we have that, then from the widget we want to add the widget to the viewport. So this is similar to the blueprint setup that we had previously. I actually misspelled the category specifier here, so I'll fix that. My recording setup is a bit awkward, so I make lots of typing errors while recording. This is also why it's a good habit to build more often, so that it's easier to find and fix those kinds of errors. Let's try that again, build and run. With the editor open in the game mode blueprint, if we play now, of course the widget will not display because we have not specified that yet. So you may expect that it will work when we choose the appropriate widget for the game widget type. So let's select our apple picker widget blueprint, compile and save. Now when we playtest, the widget still does not show up. For an exercise, deduce why our widget does not display when we playtest. Remember that our apple picker widget does not derive from our C++ widget yet, and so it does not get instantiated since we have set up the instantiation in C++. Let's go to the apple picker widget. The option to set the parent class is not in the class defaults, it is under class settings. So let's go to the graph, and the class settings button is up here. There should also be an option to reparent the blueprint in the file menu. Now for the parent class, that is set to user widget currently. Let's set that to our apple picker widget base C++ class. You should notice the setup category will appear in the variable section now. Compile and save. If we play now, the widget should show up. I'd also like to note that if you create a blueprint deriving from the C++ class using the steps that you would normally take for actors, you may run into some issues. To demonstrate, I will right-click on the apple picker widget C++ class, create a blueprint class based on that. Give that some name and click create class. Notice that the editor configuration is not what we may expect from a widget blueprint. Reparenting also does not seem to work. I will close off that blueprint. For this reason, when working with widgets, I prefer the workflow that I have demonstrated in this section. Set up the widget in blueprints, then later add your C++ logic, and then reparent the blueprint to that C++ base class. You may have noticed that the countdown timer text and the Apple selector text disappear when the countdown finishes. We only want the countdown to disappear, of course, so currently on 0 seconds following the delay, we remove the widget from its parent. One thing you may try is to remove a specified widget only. In this case, we want to target the countdown timer text. If we play now, the countdown timer widget text is removed, but the apples collected text widget remains. There is an issue with the setup, however, as we will see later. Before we continue, remember we declared a variable in the C++ class for the time remaining. So we want to replace the blueprint time remaining variable with the C++ inherited property that is in the setup category game start delay. We want to set that variable here. We also get that variable on eventic, subtract the delta time from that, and then set it to the result of the subtraction operation. So let's update those nodes. Compile and save. You can then delete this time remaining variable if you want, since we are no longer using that. Let's playtest just to make sure things still function as expected. We can now modify the game start delay, which is owned by the game mode. Let's set that to 3, for example. And remember that value is then returned by the function that we have set up and assigned to the game start delay that is owned by our widget, which is then used for the countdown timer. We can test this with different delays just to make sure things work as expected. Your apples collected text does not update yet. We will set that next. Let's revert that back to 5 seconds. Let's set the apples collected text. Search for that in the dropdown. Remember we declared that in C++ in our apple picker widget base header. When we call this, we get the apples collected and the apples to collect in order to win the game. Now what should we do when this gets invoked? Well, we want to set the text on the apples collected text widget. So at this point we know how to do this. We get a reference to the apples collected text. Then we call setText on that. Now when do we actually call this and what do we pass into it? Currently that is not called anywhere. It makes sense that we want to call this when we begin playing the game to display to the player how many apples they need to collect in order to win the game. So let's go back to our C++ game mode header and let's define an update to widget text function. We will call this every time we want to set the apples collected text. Quick actions and refactorings and create the definition. You may have noticed that sometimes it takes such a long time for IntelliSense to catch up that it may be best to just type out the definition yourself. In the definition, if we have the widget, so if that is not null, then from that widget pointer, call setApplesCollectedText and pass in our apples caught and apples to catch properties as arguments. When do we want to call this function? Well, on begin play, right? So let's navigate to that. We add the widget to the viewport here. Then let's call our update widget text function. Save those changes and rebuild. When the rebuild finishes, let's define the actual text that we will get, since if we should play now, it will be set to an empty text. We know that we want to display an apples collected text literal, followed by the actual values, separated by a /. So let's use an append operation here. Drop that down. Again, in the designer, we have the template default text defined for a reference. Now we want a similar output when we set the text, but of course we want to display the actual score as well. So back in the graph, in the first input, input A, let's set a literal text of apples collected, colon, and a space. Notice we have the add pin button here. Let's click that until we have 4 text inputs. Following the literal, we want the apples collected value, so let's connect that. Then we want a / literal. Finally, we want the apples to collect in order to win the game. So let's connect that. Plug the return value of the append operation into the in-text input on the setText node. Compile and save, and let's go and test that. If we play now, on begin play, the apples collected displays 0/3, which is correct, since we need to collect 3 apples to win the game, as set in the game mode currently. However, if we collect an apple, the apples collected text does not update yet, as we can observe here. For an exercise, you may want to deduce what to do next in order to fix this issue before we continue. Back in our game mode, on begin play, we call this update widget text. This will inform the player how many apples need to be collected in order to win the game, but currently we don't update the text when the player actually collects an apple. So let's navigate to the handle apple caught. So when we catch an apple, we increment apples caught, and then let's update the widget text again to reflect the current score. Save those changes and rebuild. Let's try that again. Playtest, and now if we collect an apple, the apples collected text will update. Now we can play around with different values to see if those update correctly. In the game mode, let's set the apples to catch variable to 5. Playtest, and that should reflect in our text widget. I will revert that apples to catch. Actually, let's set that back to 3 just for playtesting and debugging purposes as it was before. I also noticed that the apples collected literal in the widget does not have a space between the words, so let me fix that in the apple picker widget blueprint. On event set apples collected, in the append node, I will add a space here between the apples and collected. Now it looks less like a variable name or something like that. And so this is our logic to display the apples collected score to the player. We declared two functions in our widget base class, the set apples collected text and also the set game over text. I will drop that down. When this gets invoked, we want to set the text on the counter on timer text widget. That is defined right here in our apple picker widget base header. It takes in a boolean whether the player has won or lost a game. Let's go to the apple picker game mode implementation. Remember, we have the widget pointer, so when we win the game, here in the handle apple caught function, if we have that widget, then call set game over text and pass in true. Similarly, in the handle apple lost, if we lose the game, then if we have the widget, call set game over text and pass in false. Of course, you could also invoke this in the handle game over function, since we have some duplicated code now. I may refactor this later, but for now I just want to get the basic idea across. Save those changes and rebuild. Back in the game mode blueprint, when we handle game over, remember that we create the game over widget to display game over conditions to the player. Now, since we will do this in the widget blueprint, let's remove this code here. I will comment that cwbp for widget blueprint _ apple picker widget implementation. Compile and save those changes. Back in the apple picker widget blueprint, here on set game over text, depending on the boolean value that we get, we want to set the count on timer, that text widget, to you win or you lose. We can use the select node for this. This node will return an option at an index, but we can change the types. I will drop that down. By default, this takes in an index, but we can change that to a boolean. Let's right click on that return value pin and select change pin type. Click on this wildcard here. Now we can choose the type and select text. Since the set text operation takes in a type of text, so I will select the text type. Again, remember the set text function has this in text here that takes in a type of text. With that return value type changed to text, notice we now have boxes to provide text literals for each input. So when the input is false, we want to return you lose. If the input or index is true, then we want to return you win. Let's hook the return value into the set text. Compile and save. If we play test, when it is game over, the widget does not display as we may expect. That's because if we navigate to over here, we will have 0 seconds left in the count on timer logic. Following the 2-second delay, we remove the count on timer text from the parent. Instead of doing that, let's copy this count on timer text reference, and from that we can use the set visibility function. We have different options in here. We can set the widget to visible, collapsed or hidden. Of course, this will depend on what you want to do. You can set this to hidden if you want, but for this demonstration, I will use collapsed. Now when we set the game over text, we simply need to set that to be visible again. If we playtest now, when we win, that text widget should be set to you win, and if we lose, that text widget should be set to you lose. A couple of things to wrap up this lecture. Back in your Apple Picker game mode implementation, instead of having this duplicated code here, that is where we invoke the set game over text, we can put that in the handle game over function, so let's cut that out. In the handle game over function, we can now simply pass in the one game boolean, save those changes and recompile. Back in the editor, in the game mode blueprint, let's reword these commented nodes, where we created the Apple Picker widget previously to instantiate it in C++. Compile and save. Let's playtest one more time to make sure your refactored C++ code works. And with that, we are going to wrap up this lecture. I know it was on the long end, but I wanted to demonstrate the different options, since you may have to do things differently depending on the particular project. You could have done things differently here, especially with how we display the widget at the end of the game. But I think I've demonstrated some options to get you started if you want to or need to do things differently in your projects moving forward.